All right, so we're looking at the specific heat of a metal lab. We're going to be working with our Q equals MC delta T, and we're actually going to be solving for specific heat of our unknown metal. We're going to be measuring heat changes, and we're going to use a calorimeter in order to do this, which we are going to be building. We're actually going to be using our specific heat of water, which is 4.79 joules per gram degree Celsius. And we're going to assume that whatever heat is released by the metal is going to be equal to the negative heat of the calorimeter. So we've got our metal, specific heat, and our change in temperature of the metal being equal to negative mass of water times the specific heat of water times our change of temperature in our water. For our procedure, it says to obtain a calorimeter and put it on a balance and zero it. It wants us to fill the calorimeter with 40 milliliters of distilled water at room temperature and record the mass in the data table as mass of H2O. So I'm going to go ahead and remove my metal that I have on there. Our calorimeter that we're going to be working with is going to be like a styrofoam cup. So I'm going to zero this out, and I'm going to measure out roughly 40 milliliters of distilled water. So I'm going to add some distilled water to this. I've got 40 milliliters, and I'm going to add that 40 milliliters to my calorimeter cup. So as you can see, my actual mass for my water is going to be 38.16 grams. So we've got 38.16 grams. You're going to go ahead and record that into data table 1 for the mass of your H2O. I'm going to set that aside for the time being. Placing my mass of my metal back up there. We're going to weigh an unknown metal as precisely as possible. We want it to be at least 25 grams. So as you can see from this, let's see if I can get it darker. We've got 25.86. So 25.86 is our mass of our unknown metal. All right, so I've got my unknown metal. I'm going to pour this unknown metal into this test tube right here. So I'm going to go ahead and pour it into this test tube. I need to be careful to get all of it in there, so some of it likes to stick together, which is totally okay. But I'm going to go ahead and get this poured in here. All right, so now that I've got my metal in my test tube, I'm going to go ahead and I'm actually going to add this test tube of metal, and it's only metal in here, into this beaker of water on a hot plate. And what I'm going to try to do is I'm going to try to get this temperature, or the temperature of this metal, up to the boiling point of at least water. So I'm going to set this in my hot water bath, and I'm going to heat it up with boiling water, and I'm going to then let this metal sit in this boiling water for 10 minutes. So I'm going to go ahead and pause this until the water is boiling. I'll show you when it's rapidly boiling. I'll pause it again, and once time has passed for 10 minutes, we will come back to our water. While my water is heating up down at the end of my lab bench, put my hot gloves over there. I am going to show you guys how I'm going to assemble this calorimeter. So I've got a ring stand and a ring holder. This is what my calorimeter is going to sit in. For the calorimeter, I've got my 40 milliliters of water, which we already got the weight of, sitting in here to kind of keep it sturdy so it doesn't knock over. I am also going to be using a thermometer. So I've got a thermometer here. Right now at room temperature, it's reading, let's see, in degrees Celsius, 23.7. And I'm also going to be working with aluminum foil. So I am going to make a calorimeter. And in that calorimeter, I am going to have like a lid made out of some aluminum foil. And this is going to be used to kind of hold our heat in and hold our thermometer in place. So I'm going to put my aluminum foil on the outside, and then I'm actually going to stick my thermometer in there. And that, by design, is going to be our lovely calorimeter. I'll make sure to get my camera zoomed up so that you guys will be able to read the temperature of our thermometer that is going to be resting in our calorimeter. All right, so just checking in on our hot water bath. Right now it's at 62 degrees and climbing. Not quite up to a boil yet. Remember, water boils around 100 degrees. So we will check back in with the temperature when it's boiling, and then we will let it sit for another 10 minutes. All right, we are at our full boil point. If you look closely at this, it should read that it's at 99.3 right now. So our water is actually boiling a little bit under 100 degrees Celsius. And we're going to let this boil for another 10 minutes. Okay, our water has been boiling for about 10 minutes. I'm going to go ahead and turn our thermometer back on. We are on step 4 of our procedure. It says measure the temperature of the boiling water. This is assumed to be the initial temperature of the metal. This is reading at 0.8 degrees Celsius, now 0.9. So 99.9 degrees Celsius is going to be your initial temperature of the metal. You're going to go ahead and record the initial temperature of the metal down right here in your table. So initial temperature of the metal. I'm going to go ahead and remove my beaker, but I'm going to go ahead and move this a little bit before I do that and kind of slide it over so I can get my apparatus in view of the camera. Go ahead and move that over there. All right, so I've got my apparatus kind of put together, my calorimeter. Before we even get started, we want to get our initial temperature of the water in here. So step 5, it says measure the temperature of the water in the calorimeter. Record the temperature as initial temperature of water. So this is reading, as you can hopefully see, let's see if I can turn it, 23.6 is what this is reading at. And I am going to go ahead and remove my lid off of my calorimeter. I'm going to use, these are called test tube clamps. So you kind of squeeze them together like so. We've got some test tube clamps. And I'm going to go ahead and remove my test tube out of this hot water bath. And I'm going to grab the metal. Oops, it's not wanting to grab the test tube with my test tube clamp. And we're just assuming that this metal is now at the temperature of that water. I'm going to pour this in, and I'm going to quickly put the lid on my calorimeter and insert my thermometer. We're going to watch the temperature until it reaches its maximum point, and we're going to record that maximum temperature as the final temperature of our metal and the final temperature of our H2O. Go ahead and get this lidded and temperature probe on there. And the temperature is climbing. Hopefully you can see it right now. Let me turn it. There we go. So we're reading right now at 27.4. And we're going to look for our maximum temperature, which might have been 27.4. So 27.4 is going to be our final temperature of the metal and temperature of the water. As you can see now, our temperature is climbing down. So the fact that the water got up to a 27.4 is going to be the maximum temperature that it reaches. And now our water and our metal are trying to equalize. So we're having some equalization going on here. So 27.4 is what you should write for final temp of H2O and final temperature of metal. You're going to be performing some calculations on this page as well as the next page. To figure out your final temperature or your temperature change of the water, you're going to take our final temp, which was that 27.4, minus our initial temperature of water. To calculate our change in temperature of metal, you're going to take the final temperature of metal, which was 27.4, minus that initial temperature, which was a very high number. You should get a negative here. Our unknown metal that we were working with, I should inform you, is going to be unknown metal number or letter. And let me go look for that really quick. We're working with unknown metal letter E. So for those of you who are at home or remote, please make sure you circle letter E. We're going to calculate the density of our unknown metal by determining its volume and using the mass we have already determined. So the mass you had determined, I'm going to show you guys using water displacement so that you're able to figure out the volume of this metal. So I'm going to go ahead and get a graduated cylinder ready really quick. I'm going to use a 25 milligram one. I'm going to put some water in it, and then I'm going to get my metal out of my calorimeter and determine the volume of that metal really quickly. So I did not have a 25 milliliter calorimeter, but instead I found this 50 milliliter calorimeter. Our original water line is right here, so I'm going to let you guys go ahead and take your best guess as to what you think that measurement will be. I'm going to upload a picture of it as well. Okay, so I got my wet metal out of my calorimeter. I'm going to go ahead and slowly pour that into this graduated cylinder. Of course, it's a little wet, so it's kind of wanting to stick together a little bit. Almost there. 2 more spare pieces. All right, we had our water level rise. So as you can see, our water level rose quite a bit. It's all the way up here now. I will once again take a picture of this so you can identify what our change in volume was to identify the volume of your metal.